There are two concepts in geometry having to do with inequalities inside of triangles, and they get mixed up. We're going to talk about them both in this lesson so that you can compare them and be able to tell the difference when you see problems where you have to use them. Is the longest side adjacent or opposite the largest angle? Okay, well, here's the largest angle for this triangle, and the longest side is 8, 9, 10 here. Adjacent or opposite? It's opposite. What about if we go the other way? The shortest side. Where's the shortest side? That would be the 8. Is it adjacent or opposite the smallest angle? Ooh, opposite. So what if there's something special about the triangle that I just made? Let me do something to it. Let's make it bigger. Change some stuff around here and check it again. Is the longest side adjacent to or opposite? Here's the longest side. Here's the biggest angle. Opposite. The smallest angle is across from the smallest side. So that's inequalities in one triangle. Order the angles in each triangle from smallest to largest. And of course, the point is they're not going to tell you what the angles are. They just want you to know how the angles and the sides relate to each other. So if we're going to go from smallest to largest, that means the smallest angle is going to be across from the shortest side. So in this first one, 13 is the shortest side, so this angle H must be the smallest angle. Then you do the middle size one, which would be that side is 22. The angle across from that is angle F, so that's this one. And then the longest side is this 23. The angle across from that is G. So in order from smallest to largest, these angles will have to be H, angle F, angle G. 17 is the shortest side, so angle E is the smallest angle. 18 is the middle side, so the middle angle is angle F. 19 is the longest side, and so angle G? No, it's angle D. Oops! Order the sides in each triangle from smallest to largest. In this first triangle over here, find the smallest angle. That would be the 52. That means this side over here has to be the smallest side. So that would be DF. Remember the notation for a side length is a segment, so it's segment DF. Find the middle angle. That would be the 56. So the side would be FE, and the longest would have to be the one that's across from the 72. Now this isn't telling us what the side lengths are. This is just us being able to put them in order based on the angles. Okay, do it again. How about you pause the video and see if you can do it, and I'll come right back and show you. Okay, 41 is the smallest angle, so BA has to be the shortest side. 51 is in the middle, so then it would be side length CA, and then 88, and that would be side length BC. That's how you relate them and how you can put them in order. Pretty simple thing, but it always gets mixed up with this thing, the triangle inequality. The questions you're going to be asked are, given these three side lengths, can I make a triangle? Because you can't always make a triangle. And if I put them together like this, you start to get an idea of what the problem is. This one is too short. The idea of the theorem, the Triangle Inequality Theorem, is that if you were to compare the two sides, the two shorter sides to the longer side, you see how they don't even add up to equal the longer side? And if they did equal the longer side, like just straight up equaled it, you still wouldn't really be able to make a triangle. You would not be able to get these corners together. See what's happening? There's a gap. So in order for this to work, you have to make these sides longer in some way so that the two side lengths, when you add them together, are actually going to be bigger than that third side. All right, so in this situation, with this example, AB plus the length of BC, 9, has to be bigger than 10. The length of BC, which is 9, plus 10, which is length CA, has to be bigger than 7. And then the last one is 10 plus 7 bigger than 9? And if these are all true, then you can make a triangle with those three numbers. And this is what the problems are going to look like. Can you make a triangle with these three numbers, 9, 10, and 3? So I'm going to take 9 plus 10, and I'll be comparing that to 3. Is that true? Yes. And then I'm going to take the 10 and plus the 3 and compare it to the 9. Is that true? Yes. And then the last pair would be the 9 plus the 3. Is that bigger than 10? Yes. So the correct answer here is yes, I can make a triangle with these three numbers. So hopefully this is a no example, so you can see what goes wrong. We have 9 plus 21 equals 11. Or how does that compare to 11? I misspoke. Is that true? Is that bigger? Yes. And then I take the 21 and 11 and I compare it to a 9, and that's a hell yes. And I'm assuming this is going to be the problem. 9 plus 11. 9 plus 11 is 20. 20 is smaller than 21. So that's a no. That means we're going to have a gap. Like in that example I just showed you on the demo, you would try to put these sides together and there's going to be a gap in between a couple of sides. So there is no triangle happening with a 9, 21, and an 11. The harder version of this problem is when they give you two sides and they ask you to give them options for what the third side could be. Some people are going to go after this with guess and check, but there's an easy way to do this. Set this up. There's an X. There's some unknown number that would be the third side with the 12 and the 10. And that X has to be between numbers. That's why they're saying range. The smallest value that could be is 12 minus 10. And I'm saying it can't be that. It has to be bigger than that. And the larger number is 12 plus 10. And so your X for that third side, it has to be between 2 and 22. All right, if you think you understand, pause the video and try this one. I am about to do the problem in 3, 2, 1. You have to practice these. Don't skip the homework on this. It's because it's going to be the repetition of this that's going to help you remember this. The bottom number is going to be 8 minus 7, and the top number is going to be 8 plus 7. So we're going to go from 1 to 15. Doesn't that make it easy? I love that. Love that. Comparing these two, you're going to use the inequalities in one triangle idea to put your sides in order or your angles in order. You use the triangle inequality to determine if you can make a triangle out of three given sides or what could possibly be a third side. Hey, if you like how I teach, I've got another video for you. Click into that one and I will see you over there. Thank you guys. Bye.